Hello everyone, this is Xiong, Jordan, and Kyle here at CVTC. We are in our 4th semester. Welcome to our project. Today we're going to be looking at how to use two PLCs to communicate through Modbus protocol to control a variable frequency drive. We have our master PLC here, our slave PLC, and our variable frequency drive, which is our GS2. Let's go ahead and break down and so we can see what's going on.
Alright, so right here we have our wiring diagram for our master PLC. We have a master control relay down here that's in series with the red stop buttons, and then it'll send a signal to stop the PLC. The rest of these are all push buttons, and then we got our two limit switches right here that are controlled by the pneumatic cylinder. And then we got all our outputs over here. We have two pilot lights, two solenoids, and two more pilot lights. Now we're going to move over to the pneumatic circuit of the process. Here we got our lower cylinders, which corresponds to the cylinder right here. This shoots the ball up. Over here we got our upper cylinder, which catches the ball, and they are both controlled by solenoid actuated control valves. This is the lower limit switch and the upper limit switch. Moving on to the slave PLC, we got our output from our drive going to input 4 on our other DL06. We got our master control relay circuit contact from the safety circuit of this PLC. And then we got our outputs from the PLC going to and now we're going to go to the GS2 drive. We have put parameters in here to spin up the drive at a certain frequency in a certain amount of time, and that's controlled by inputs from the slave PLC going to the drive. And we also have some outputs coming to here to tell it when it's set.
Now we're going to talk about the programs that we have set up in here.
So first we have our master PLC, which sends signals, which we use send and receive instructions to send signals to our slave PLC here. This is the first sheet of logic. I have a bunch of comments, a bunch of internal bits. This is a drum sequencer that we were introduced to. It runs the master PLC through a specific sequence, sending signals at specific times and illuminating lights and stuff like that. The first page. It's our second page. We just have a bunch of this is our receive instruction. We have all this is our solenoid for our cylinders and our pneumatic trainer. Down here we have some errors, just in case we don't have pressure. Both limit switches are made at the same time. Just a bunch of different things to account for anything that could happen. More errors and some time delays to compensate for the ball travel, stuff like that. We have our last send instruction here to send to the slave PLC that we've stopped the circuit and it is ready to resume its program. Now on to our slave PLC program. We have one receive instruction here because we couldn't get it all into our master PLC because they were interfering with each other, either through the communication or something. It was just not working, so we put a receive instruction in our slave PLC instead of a send in our master. But we have signals going out to the frequency drive to tell it to ramp up to 30 hertz, stop for 2 seconds, and then ramp up to 60. And then once it's at 60, the VFD sends a signal that it's done to the PLC, which is right here. And this enables a bit which sends it to our master PLC to resume the sequence.
Alright guys, so now that we know more about each individual component, we're going to see how our program actually works. So when we press our green button, it's going to illuminate each light individually. Once the last light has illuminated, our cylinder will shoot the ball and it will also catch the ball at the top. Once the ball has been caught, our master PLC will tell our slave PLC to turn on our drive, and we're going to go to our first speed, which is set at 30 hertz. From there, it's going to hold for 2 seconds, and after 2 seconds, it will go ahead and ramp up to its final speed, which is 60 hertz. Once it has reached 60 hertz, the ball will drop and the lights will turn off in sequence by the order they were turned on. So once we have all that, our program will be complete. So here we go. All right, thanks for watching, guys. That concludes our demonstration.